Hey everyone. So what I'm going to do today is take a look at the unit test. This is in the Algebra 1 class on Khan Academy. So if you go to the Algebra 1 class, go to the functions unit, and I'm looking at the unit test. So what I have here on the side, and just before we get started, this is meant for the Algebra 2 level. So this is an Algebra 1 set of questions. It's an Algebra 1 test, but it's meant for Algebra 2 students. So students that should have an understanding of the basics of functions, and also like operations, equations. And what we're going to do here is try to speed run more or less as best we can. So it's 19 questions. I'm going to try to do a minute per question. So limit it to 19 minutes. Doing the questions, what I'm going to start with is just reviewing what a function is really quickly, because I think it is useful. So I have my definition of a function up in the top left here. It says function, a corresponding set of inputs and outputs. So I think it's pretty basic definition. So what I want to do is think about kind of what that means. If you think of graphs is kind of the way that it's typically thought about in math. And when we think about graphs, there's typically kind of two planes, right? X and Y. As you can have a graph like this. And actually, why don't I kind of draw a few little graphs here? So why don't I do a little vertical here, a little X and Y. So this will be function 1, and I'll just kind of very roughly sketch these very roughly. And then here, all right. So what I'm going to do with minimal precision is just kind of talk through some X values here. So if I have some inputs, so a function is a set of inputs and outputs, and they're corresponding, which means every input has to have an output associated with it or corresponding to that input. Right, so every input has an output that's linked to it. So if you think of the word corresponding, you can think linked. So every input has an output that is linked. So that's kind of how we think of it. And if there's an input with multiple outputs, that cannot happen. That is not considered a function. So if any one input has multiple outputs, that is not considered a function. That's kind of one of the main things to understand when you're thinking about functions. So let's get some inputs here. Let's just say -2, -1, 0, 1, and 2, and see if we can fit all of those in there. So I'll make some little lines here. So we're going to do -2 to +2, and just see what kind of shape we can get. And it's really just trying to understand the inputs and outputs. So every function is inputs and outputs. So these x's are my inputs. So -2, -1, 0, 1, and 2 are my inputs. And here I have actually 3 different functions. So when we think of functions, this is kind of the rule that we're going to use here. So if you look at the first function, it says the function in terms of x, this means here, the function in terms of x, f of x, is equal to -3 times x. So what this is saying is that there's a rule here. This function has a rule. Every function has a rule associated with it. This rule is that the y value, or the output, is -3 times the x value. Or it's actually, yeah, -3 times the x value. That sounds right to me. So we're going to think of the x value. Here is -2. So that would mean I would have -3 times the input of -2, because all I'm doing is taking the number here and putting it in for x, taking the input and putting it in for x. So this is going to be +6, right? Negatives times negatives positive. I won't go over too much of that kind of stuff since this is an Algebra 2 review. So just kind of speeding through here. So our outputs would be +3, 0, anything times 0, 0, times 1 would be -3, and times 2 would be -6. So our graph would look something like, so 0, 0. I have 1, -3, something there. 1, 2, -6, maybe there. This will be a straight line, -1, 3, and we'll say -2, 6. So I hope you can see, even though I'm just roughly doing this, that's kind of what that function would look like. The second function, input of -2. So what I'm going to do here, in this function, the rule is, so in terms of order of operations, first thing I have to do, square the input. So for me, -2 is the input, -2 squared is +4. So it's going to be 2 times +4 plus 1. So that's going to be 8 plus 1, which is 9. All right, so I'm just going to kind of speed through the rest here. So -1 squared is +1. So that is the x squared is +1. That's times 2. So say 2 times 1. X squared is 1 plus 1. So say that is 2 plus 1, which is 3. 0, so this is all going to be 0 plus 1 is 1. 1, so 1 squared is 1, 2 plus 1 is 3, and 2, so 2 squared is 4, times 2 is 8, plus 1 is 9. And that makes sense that it's symmetrical because this is quadratic. So it looks like we have 0, 1, and that will be our y-intercept. That'll be our vertex for this as well. Let's see. So I have 1, 3, and negative 1, 3. So 1, 1, 2, 3. And mirror that, negative 1, 3, and then 2, 9. So 1, 2, and then 3 times that high. So maybe up here, and then negative 2, and then maybe 3 times that high. So maybe up here. And I can't use the line tool for this, and that was terrible because it is quadratic. So I have to curve it. And that's not a really great curve, but it will curve, not a straight line. So it's kind of look like that. And then f of x is 3. Ah, nice. I'm glad I put this one in. So the inputs here are -2 to +2, but with this function, the rule is that the output is 3. So it does not matter what the input is, the output is 3. So I can totally disregard all these inputs. The rule for this function is that the output is 3. F of x equals 3. The function in terms of x equals 3. At all times it equals 3. Doesn't matter. For any input, the output is 3. So that would be I can do it point by point. So if I do 0, 3, 1, 3, 2, 3, negative 1, 3, negative 2, 3, just have a horizontal line there at 3. Totally flat line 3. All right, so what we're going to do now is I will start my stopwatch and do 1 minute per question. So this should help you at the Algebra 2 level kind of get a feel for this. And what I'm actually going to do is, I think, erase the writing here so I can write myself. All right, so I have the stopwatch ready, 1 minute per question. I have not opened the test yet. On this account, this is my first time taking it, so it should be hopefully a little on the simpler side. As you take it more and more, it will get harder. And later, I'll do this again as it gets harder, I'm sure. And yeah, see what that looks like. So let's take a whack at this first time through and see how we do. All right, stopwatch has started. Oh my goodness, need to stop. Okay, so this is unfortunately, or what I'm working with at the moment is this kind of area here. And I'm going to start the stopwatch again. I will write as much as I can, maybe try to solve 2 or 3 before having to erase, and we'll see how that goes. All right, stopwatch is starting. All right, this says, what is the inverse of the function g of x 5 times x minus 2? Nice. So I have a fun one. So this is inverse. So I have y equals, I'll use y instead of f of x, 5 times x minus 2. In order to find the inverse, I need to switch x and y. So I'll say x equals 5 times y minus 2. All I did was switch. Now I need to solve in terms of y. So x is 5y minus 10. 5y, I'll add 10 to both sides, equals x plus 10. And divide both sides by 5, so y equals 1/5 x plus 2. 10 divided by 5 is 2. So let's check this answer here. So we'll say 1/5 x plus 2. Nice. 49 seconds. All right, I will just reset. Start. Okay, this is what is the domain of g? So this is a square root function. So the main idea here is that you cannot take square roots of negative numbers, right? So basically, if this turns out to be negative, we cannot evaluate that function because you can't take the square root of negative. So the thing is, this could be negative, it could be positive because it's x plus 3. So what we need to do is figure out for what values of x will this be negative. So let's say x plus 3, that's what we're interested in because we're taking the square root of that. When will that be negative? So when will that be less than or equal to 0? So I will subtract 3 from both sides. X needs to be less than or equal to -3. So if x is less than or equal to -3, things are going to fall apart. Things are not going to work. So we'll say all real values that where x is greater than that. So let's go B. Very nice. 51 seconds. All right, let's pause here for a sec. All right, just wanted to erase there. Okay, does the graph represent a function? Okay, so all we're looking for is, with a function, we said it's a corresponding set of inputs and outputs. And the one real thing you're looking for, the one thing that can't happen with that set of inputs and outputs is there can be no input with multiple outputs. There could be no input with multiple outputs. So we need to look for all the inputs, all the x's. So here x is -7, and there's only one output, and it's 3. So this is the point -7, 3. Right, so I can look at all my inputs, my x's. Are there any x's with multiple outputs? -3 has 1, -1 has 1, 3 has 1, 4, 5 has 2. So this input 5 has 2 outputs. So when x is 5, when the input x is 5, there are 2 y values, there are 2 outputs. That cannot happen. So this is not a function. That is not a function. No. All right, next question. Let's pause for a sec. All right, the table below shows some inputs and outputs of the invertible function f. I'm not even exactly sure what that means. With domain, all real numbers. So any x will work here, I can put in any x. Oh my goodness, so find all the following values. So these are kind of compound functions here going on. So we just need to understand the notation. And is my timer on? Sorry, is my timer going? No. Yes, all right, starting now. So f of 93, so when I plug in 93 for x, remember, this is f of x. So the number in the parentheses here is representing x. So when x is 93, what is y? I do not see an output when x is 93, but maybe we can find a rule for the function. I guess that's what it's asking us to do. Let me pause this for a second and see if I can figure that out. All right, so I just watched the Khan Academy video and checked on YouTube. Basically, seems like an invertible function is just a function that can have an inverse. So a function where an inverse function is a function as well, where an inverse function is possible. I don't know how I'm going to find f of 93. I don't see that input. I'm just going to guess. So this is what you should do on Khan Academy. I could try to figure this out. I'm just going to guess. So if you don't know, you could use the hints. So am I stuck at a hint? So I'm not going to spend the time to figure this out right now. So I will just say skip for now. Right. So you can also feel free to do that. You can always do that. It's a great thing to do because it helps not waste your time. It's not worth wasting your time. All right. So here, let's start the time again. Set. Minute on the clock. All right. So this is saying f of t is 2t minus 3. So the rule for this function is 2t minus 3, 2 times whatever input, and then minus 3. So when the input is 7, it's going to be 2 times 7 minus 3. So that'll be 14 minus 3, which is 11. So I'll type in 11. Awesome. All right, let's erase. All right, so let's do our best to see everything here as I do the opposite. So this is a graph question. A graph is just a picture of a function. A graph is a picture of a function. So within this graph, the input is W, which is P of W models Jada's weekly profit. So the profit is Y. So where negative profit means she lost money as a function of the total weight of paprika she sold. So W, the input of this function is W, which is the weight of paprika. So how much paprika? So let's just say in kgs. Oh yeah, it is in kilograms. So let's just say kgs of paprika, of paps, right? So how many kilograms of paprika did this person sell? And then the output is how much money they make. And it looks like the break-even point is 35. So when this person sells 35 kilos of paprika, they break even and they actually make no money. So let's see what it's actually asking. I have basically no time left. What is the y-intercept? Where does this graph cross the y-axis? That's very negative, negative 250. And that's if she sells nothing, she loses 250. I like that. Positive or negative interval, it's negative if it's less than 35. So the function is negative when the input is less than 35, positive when it's more than 35. So say the more paprika Jada sells, the more profit she makes. That's true. Jada needs to sell more than 35 kilos in order to make profit. That's more clearly corresponding to the positive and negative concept because that 35, that's that break-even point, where if you're to the left of it, everything's negative, and to the right, everything's positive. So let's go with this. Very nice. All right. All right, so this question says, mark all the relative maximum points in the graph. Cool, so it's interactive. So relative maximum. So when I'm looking at a relative maximum, I'm looking at peaks. So where are the high points in different areas? So this, if it's like a little mountain range, it has kind of 3 peaks. I think a peak here, and a peak here. So I'm going to like that. I think I'll call these the relative maxima, plural. Very nice.